Today we're going to talk about balancing chemical equations. Chemical equations must always be balanced due to the law of conservation of matter. You've probably learned about this in other science classes before. The second law of thermodynamics states that matter can't be created, it can't be destroyed, but it just changes forms. So when we balance an equation, we always have to conserve the number of atoms on the reactant side and the product side, and also the charge on the reactant side and the product side. Atoms is pretty straightforward. In terms of charge, oftentimes we're talking about a transferring of electrons in a type of chemical reaction. Redox reactions are reactions we talked about in class where one chemical species is giving up electrons and another chemical species is picking up or receiving those electrons. In that particular example, if 3 electrons are given up, then 3 electrons must be accepted by something else. Electrons aren't created or destroyed either. There's an important distinction to make when we balance chemical equations. There's 2 different terms that we use to describe the number of molecules and the number of atoms that we have. One of them is called the coefficient. The coefficient is the number in front of a molecule or compound in a chemical equation. And the coefficient represents the number of molecules or atoms used in a chemical equation. It is the coefficient that you can change in order to change the number of atoms when you're balancing. The second type of number is the subscript. A subscript is the number of atoms used in a compound or formula, and the subscripts can never be changed on a compound, or they will mess with the ratio of atoms that you have to make that compound. So, if we take a look at this example, we've got 2 moles or molecules of sulfuric acid. If I wanted to know the number of atoms of each type of element present, I would use the distributive property of math. The 2 out in front applies to every single element within sulfuric acid. So in order to figure out how many atoms of hydrogen I have, I know that in every 1 mole of sulfuric acid, there are 2 atoms of hydrogen, 1 atom of sulfur, and 4 atoms of oxygen. If I have 2 moles of sulfuric acid, in order to figure out the number of atoms of hydrogen, I would do 2 times the 2 hydrogen, so 4 atoms of hydrogen, 2 times the 1 for sulfur, for a total of 2 atoms, and then 2 times the 4 for oxygen, for a total of 8 atoms of oxygen. A few strategies that we use for balancing chemical equations are as follows. Number 1, it is only the coefficient, or the number in front, that we change. Sorry, the lecture got interrupted for a minute. So it's only the coefficients that can be changed to balance chemical equations. Secondly, we always want to start with elements that show up only once on each side of the equation. We'll see this in our next example. And then third, you save the reactants and products in elemental form, especially hydrogen and oxygen, for last. Let's take a look at our examples here. In the first example, we have magnesium chloride being combined with sodium bromide to make sodium chloride and magnesium bromide. You might recognize this as a special type of double replacement reaction. The first thing that I want to do when I'm balancing a chemical equation is I want to take an atom inventory, where I separate out each type of atom that shows up on the reactant and product side. After I separate out each type of atom, I count the number of atoms that I have on each side of the equation. On the left-hand side of the equation, we have 1 atom of magnesium, and on the right, we also have 1. For chlorine, we have 2 atoms on the left, and we have 1 atom on the right. So at this point in time, we can see that we need to balance this chemical equation before we move forward. For sodium, there's 1 atom on the left and 1 atom on the right. And then for bromine, 1 on the left and 2 on the right. So one of the strategies that we said is that you always want to start with atoms that only show up once on each side of the equation. Well, that strategy really doesn't apply here because I only have magnesium in one place here, and I only have magnesium in one place on the product side. And the same can be said for every other atom that I have. Chloride only shows up in one compound, sodium only shows up in one compound, and bromine in one compound, and the same on the product side. So we can kind of skip that strategy for now. In this example, I would just work top to bottom, left to right. Magnesium is currently balanced. I would move on and look at chlorine. What I'm looking at is how do I get chlorine on the right to have two atoms? So I'm looking at what can I do to change this coefficient to make this 2? I simply just need to put a 2 in front. So by putting a 2 in front, I'm multiplying the number of atoms of chlorine by 2, and I get a total of 2 atoms of chlorine. When I put a 2 in front as the coefficient, that affects every other atom in the molecule. So now I need to update my number of sodium atoms. I now, instead of have 1 sodium atom, I have 2 sodium atoms. Now that sodium is 2 on the product side, I need to change the reactant side to reflect that. In order to make this 2 for sodium, I need to simply multiply it by 2, and so I use 2 as my coefficient here. That not only changes sodium atoms, but it also changes bromide atoms. So I have 2 atoms of bromine, so I will update that on the left. On the right, I already had 2 atoms of bromine, so it looks like we have successfully balanced our equation. Our second example is a little bit more complicated, but it's still fairly simple. In the second example, we're looking at the combustion of methane gas. Methane is a natural gas. It's what's used to heat most of our homes. That's what the CH4 is. So in the presence of methane gas, we have oxygen, in the presence of oxygen, we have methane gas burning and combusting to make CO2 and water. And if we look at it, it is not currently balanced. We have 1 carbon on both sides, but as soon as we look at hydrogen, we see that there's 4 on the reactant side and only 2 on the product side. So as soon as we recognize that, we start with our atom inventory. We've got carbon atoms, hydrogen atoms, and oxygen atoms. 1 atom of carbon on each side of the equation, 4 atoms of hydrogen on the left and 2 on the right, 2 atoms of oxygen on the left, and 3 on the right. So again, with the strategies, we always want to start with the element that is only showing up in one place on both sides of the reaction. On the left, carbon would apply. Okay, carbon is only in the methane molecule on the left, and carbon is only present in carbon dioxide on the right. So that would be a good one to start with. Since carbon is currently balanced, I'm going to move on to the next one. My 2 remaining options are hydrogen and oxygen. Hydrogen is the one that I want to balance next, simply because hydrogen is only in one place on the left. It's only in the methane gas. It's only in one place on the right, in water molecule. Whereas oxygen on the right-hand side is both contained in the carbon dioxide and in the water molecule. So oxygen is going to be the atom that I want to balance at the very end. The other strategy that we mentioned is that when you see an element all by itself, this is what you want to balance last. So we're going to write balance atoms in elemental form last, especially if they are oxygen or hydrogen. Okay, so now in order to balance my atoms of hydrogen, I need to multiply this by 2 to get 4, which means that I'm putting a 2 as my coefficient in front of water. Now that I've balanced hydrogen, this 2 applies not only to the hydrogen, but also to the oxygen. So we need to update our atom inventory. We have 2 atoms of oxygen over here in water and 2 atoms in carbon dioxide for a total of 4 instead of 3. I only have 2 atoms of oxygen on the left, and so in order to make this 4, I need to put 2 as my coefficient in front of oxygen. Now I've updated all of my atoms, and this is a balanced combustion equation. They will get a little bit more complicated on your worksheet, so just make sure you practice, but use the same strategies as they get more complex.